So, thank you for coming to my channel. Today we're going to be talking about polymorphism, and we're going to specifically talking about how we can implement polymorphism in Python. For today's discussion, we won't be going into inheritance. We're going to be talking about how we can do polymorphism without inheritance, and we'll get to that in a second. So before we dive too much into the implementation of it, let's just go over a little bit about what it is. So I just got this definition online from a website, and what they said polymorphism was a language's ability to process objects of various types and classes through a single uniform interface. And this might seem like a lot of buzzwords, but to put it down in layman terms, the idea of polymorphism is being able to treat different objects the same way through a common interface. And we'll focus on this word right here, interface, and we'll go into detail in a second about what that means. So before we dive into Python, let's look at a programming language where polymorphism is very easy to implement and is highly encouraged through the language's actual built-in features. So if we take a look at Java, Java is able to create this idea of polymorphism or this idea of is a relationship through interfaces and inheritance. And so if you don't really understand what polymorphism is yet, here's a pretty good example what it is. So in Java, we're able to create this thing called an interface, which we have up here and we're calling it animal. And this interface has two methods inside of it called animal, sound, and sleep. And the idea of this interface is that any class that wants to implement this interface needs to define at the very least these two methods. So you see how up here these two methods don't have a body? They're empty. But if we look down to, let's say, pig and cow that both implement this animal interface, they both have an actual concrete definition of animal sound, this first method, and sleep, this other method in animal. And so what this enables us to do is, say for example, we created a main, so on the right hand side, and we created a new array list. And what we wanted to do is we wanted to create an array list of animals. So to this list, we just add a cow, a pig, a cow, and a pig. And the beauty of polymorphism is that inside of this for loop, we're able to treat both cows and pigs in our list the same exact way. So in the first line in our for loop, we're able to first get each item from the list and assign it to a variable. And here we don't really have to write some code that says, hey, if the thing that we got from our list is a pig, let's do something. Or if the thing that we got is a cow, let's do something. We're able to kind of generalize it here. And we're able to just say, hey, let's take this animal and let's call the animal sound method that it implements. Or let's take this animal and let's call the sleep method. And so with that, if we were to run this code, what happens is in our output, the first thing that we added was a cow. And so the cow's two methods are executed. So we first have the animal sound because that's what's first in the for loop, and that's where it says the cow says moo and moo, and then it says sleep, so the cow says mm. And the same thing then happens with the pig, since the pig is the second thing. And so now we have the pig says wee wee, and the pig that sleep sound is z. And so we have the same thing repeat again, since we had just a repeating pattern where we first added a cow, then a pig, then a cow, and a pig. So we would see that these two would just be copies of each other. And you see how it makes the implementation a lot easier because we don't have to write an if statement saying, hey, if this animal is a pig, let's do some stuff. Or if the animal is a cow, let's do some stuff. We might want to add some class specific stuff later on, but the beauty of polymorphism here is that we're able to say, hey, a cow is a animal. So a cow should have the animal sound and sleep. A pig is a animal. So the pig should have an animal sound and a sleep method. So in Python, we don't really have support of interfaces out of the box unless you use some other library like collections or something like that. So what we have to figure out is how can we achieve the same result without interfaces or inheritance? And so yeah, let's just code it along. It's actually pretty easy. So if I go to my code editor and let's maybe do the same example where we have a class and let's make a cow. And inside our cow, what we want to do is we want to create a couple of methods. So the first method we'll create is, let's say, uh, we'll call it moo. And all this will do is it will just print out moo. And let's say that we also wanted to say something like um, the sleep sound that we defined before. So we said, and let me just align my tabs up. So we say sleep. And here, let's say that we're going to print out, and we'll make this a little more descriptive here, and we'll say the cow says moo. And let's take the same definition, and now let's make a pig class. So we can replace this with pig, and let me just make this a little bit easier in terms of spacing, so that way everything can fit on the same screen, and we'll lower this down a bit. So let's say the pig can say something like oink, and we can say here the pig says oink. And here when it sleeps, we'll just say that it makes the z sound. So now if we go to our main function, so let's make a main, and let's call it down here. And let's say here in our main, we want to create a list of animals like we did before. So we can make a variable animals, and we'll just make it a list. So the first thing will be a cow, the second thing will be a pig, the next thing will be a cow, and the next thing will be a pig. So now we have a list of 4 objects, 4 animals. So if you wanted to iterate through it, so we can say something like for animal and animals, now we really run into a problem, right? Because if I say something like, let's say animal dot moo, and I would run this code, and I forgot to add self to all of these because these are methods, so self is always the first argument. And then we have here where the cow says moo, but we get this error, and let me just bring it up a little bit, where since the first thing on our list was a cow, it has the moo method, but the second thing is a pig. And so here's where we have to special case it and say, hey, if the animal is a cow, let's do some stuff, and if the animal is a pig, let's do some stuff. And there's multiple ways to do this. We could use the type built-in method, but that doesn't really do a lot of things. It's not very powerful. One thing that we can do is in our constructors, so if we say up here, we can create some type of name property. So we can say something like self.name equals cow, and we can take the same idea where we plug it out in here. And here we can say something like the self.name equals pig. And then this is the way that we can special case it, and we can say something like, hey, if the animal.name equals cow, let's do, we know it's a cow object, so it's able to use moo. Otherwise, if the animal.name equals, and although we could have done an else block here, I just wanted to pretend like, say we had a bunch of different types, like we had cows, pigs, sheep, horses, we would have to write if statement for each type because we want to special case it. So let's say here, and let me just make this a little bit smaller so that's easier to put everything on one page. Here we can say something like if it's a pig, then let's do animal.oink. And so this is how we could run everything. So this is how we can say the cow says moo, the pig says oink, the cow says moo, the pig says oink. And we can even add onto it and say something like animal.sleep. And we can also say down here, yeah. And so or actually I'll remove that part since we'll get to that in a second. So you see how we had to write our conditionals here, and it really doesn't do anything for us because it adds extra logic to how we implement our classes. So the idea of polymorphism is that we are able to treat objects the same way, and to do that, all we need to do is just name this methods the same name. So instead of having this logic where we have to create a name property and we have to check its type before we just do stuff, we can say something like make sound. And we can say, we can take this method that we called make sound on cow, and we can implement the same method in pig. So we can put a make sound up here. And the beauty of it now is all I have to say is animal.makeSound. And I can also say animal.sleep. And so when I run this code, we are able to print out everything. So this is this idea that's fundamental to polymorphism, is that we're able to take objects that are different, so class pig and class cow that are technically 2 different objects, but because we implemented the same interface, so meaning that they both have the make sound and sleep method, we're able to treat them in the same way. Now we could do that same stuff that we did before. So if I go back to what we had before, if maybe later on we wanted to add some implementation specific details and say, hey, a cow should have a specific method or a pig should have a specific method, then we could add this logic here. But for our uses right now, this is a great way of creating a generalization to help reduce this code complexity. So if I go back to the last thing, so let's wrap up on polymorphism. Like I reiterated from the top, this video is about just polymorphism by using the same method name, not going over inheritance. That'll probably be a future video. But just want to talk about an advantage of polymorphism is we're able to reduce the implementation complexity of a class, as we saw here, and we don't have to really write any if-then logic to say, hey, if an animal is this type, let's do some stuff, or if an animal is this type, let's do some stuff. We're able to kind of just create the same we're able to use it the same way through this common interface. But some disadvantages that we can talk about is if used incorrectly, we could cause completely different objects to be related. So let's say that we had a horse class or maybe a even a person class, and maybe they have a make sound or they have a sleep. Maybe those two sleeps between a human class and a pig class are different, so that might cause some weird uh, relationships that maybe shouldn't exist. And the last thing is more generalized naming. So beforehand, we're able to call this something like moo, and in the pig class, we're able to call make sound oink, which can be maybe a bit more descriptive. But because we have to use the same name, we had to generalize it so we can make it make sound. In our case, it's fine, and I don't see anything wrong with that. But when you have more and more classes and you're trying to use polymorphism, you might run into the issue where you're creating very generic names like speak or sound. And so that's just something they should keep out for. And so I think that's a great way to wrap it up. So just this is a good trick to use whenever you're in a coding interview and you have to create multiple classes and you want to use them the same way or maybe on the job. And so yeah, if you have any questions, just post them in the comments below. And thanks again for watching.